Hello and welcome to this video lesson. In this video, we will be looking at the derivation of the velocity with respect to displacement equation for simple harmonic motion. All right, we're going to start off with writing the equation for position here. So that's x is equal to the amplitude times sine of omega t. We can write the plus phi, which explains the shift for other forms as well, but we'll skip that one for this specific derivation. I think that's a very small addition that you can easily add and figure it out. In terms of the position here, our starting position is the equilibrium position, and we got period of t. To get the velocity, velocity is the rate of change of position with respect to time. So we have to use the product rule and the chain rule. So for the product rule, I get a constant. Remember, this amplitude is constant, and 2 pi over the period is also constant. So this omega is also a constant value here. T is variable and position is a variable. So for using the product rule, we got the constant, the derivative of the constant here is 0 times sine omega t is 0, plus the derivative of this function multiplied by x naught. So the derivative of the sine function is negative cos omega t, and the derivative of the inside for the chain rule is just omega. The derivative of omega t is just omega, and we're multiplying that by x naught, which is the constant. So this is a mix of product rule and chain rule in action. Now the question is, how do we get from these two to this? It's a very, very clever math that's being used here. So I'm going to square the first function here. So that's 1 squared. And I will get x squared is equal to the amplitude squared sine squared omega t. I'm also going to square the second function here. So 2 squared, which will give me v squared is equal to omega squared amplitude squared cosine squared of omega t. Now what I'm trying to do is getting rid of these functions over here. So I need to do something in order to use an identity that will kind of get rid of these. And to do that, again, very cleverly, I'm going to take let's say this is now my third equation. I'm going to divide both sides of 3, or rewrite 3 as v squared over omega squared is equal to the amplitude squared cos squared of omega t. And now this is becoming somewhat interesting because I got cos, like I can factor these two and add these two together, and sine squared omega t plus cos squared omega t gives me 1. So let's do that. So I am going to label this equation as 4, and I'm going to do 3 plus 4 here, and I'm going to get x squared plus v squared over omega squared is equal to x naught squared sine squared omega t plus x, or amplitude squared cos squared omega t. And now I can write it as position squared plus velocity squared over angular velocity squared is equal to, and I'm going to take the amplitude, factor it out, and I will get sine squared omega t plus cos squared omega t, and this whole term becomes 1. So I'll continue this over here. And now I have position squared plus speed squared over angular speed squared is equal to the amplitude squared. I'm going to subtract position squared from both sides, and I get this. I'm going to multiply both sides by omega squared. And I'm going to take the square root of both sides, and I will get this equation over here. And this is extremely useful because we're writing the speed or velocity of the object with respect to its position. So as long as you know the period, and you can figure out this term over here because that's 2 pi over the period, and you can square that. You know the amplitude, you can just get that from the graph, and you can look at any position and you can figure out its speed based on that. And if we look at this, we know that the speed is maximum when the object is at the equilibrium position. So let's say any of these 3 points. And at that point over here, omega squared times the amplitude squared square rooted, we can get the maximum velocity, V max, is going to equal to, this is, let's say this is speed, so we don't care about the plus or minus. It will become omega squared times the amplitude. So a very useful equation, but the derivation is really clever, and it's really useful for physicists and scientists.